The first example we'll be looking at is going to be problem 1 in chapter 9. In this problem, you're trying to come up with an optimal production schedule for creating 3 types of bookshelves. Whenever you're dealing with an optimization problem, first you need to answer 3 questions. And as you can see, I have divided the spreadsheet into 3 portions that correspond to these 3 questions. First, what are you trying to decide on? What are your decision variables? Here we are trying to decide on how many standard bookcases to make, how many narrow bookcases to make, and how many wide bookcases to make. The next question is, what is your goal? What is your objective? In this particular problem, we would like to maximize our profit. And your objective in our problems is going to be either a maximization or a minimization. The third question you ask is, what are your restrictions? What are your constraints? We have 3 operations each bookcase need to go through: the trimmer operation, the shaper operation, the assembly. And here we're given how much time each operation takes for each type of bookcase. Then we have the capacity in hours, how much time we have available. Now, the ultimate goal is to find the best production schedule, best decisions that will give you the best profit. But before you get that, what you would like to do is create a worksheet that lets you try out different scenarios. So let's say I decide to produce 1 standard, 2 narrow, and 3 wide bookcases. And given this particular schedule, or given any schedule, I'd like to be able to find the total profit, and I'd like to figure out whether I'm using enough of the capacity or I'm going over capacity. What I need to do in this workbook is add some more intelligence to it. So once I enter the decisions, I need to calculate the profit, and I need to calculate how many hours of each operation I'm using. To do this, I'm going to use the SUMPRODUCT function, which we have seen before. SUMPRODUCT of this array with this array will give me my total profit. So if I'm making 1 standard bookcases, 2 narrow bookcases, and 3 wide bookcases, I'm going to make a total profit of $50. Let's also make sure that these are formatted properly. Perfect. Now the next thing I would like to do is figure out how many hours of each operation I'm using with this particular production schedule. Now again, for example, for trimmer, I need to do 0.2 times 1, 0.4 times 2, 0.6 times 3, and that's what the result here should be. If you notice that that's very similar to my formula here. In fact, I set up my spreadsheet so that if I use my absolute referencing smartly, I don't need to retype the SUMPRODUCT formula over and over again in F11, F12, and F13. So here's what I'm going to do. I'm going to highlight C5 through E5, because as I copy paste this down, I don't want the blue references to change. I push F4. Now I'm going to copy this formula, and then I'm going to paste it formulas only here. And let's look at one of these formulas. For example, here, as you can see, I have SUMPRODUCT of C5 through E5, C12 through E12. So now I also know how many hours of each operation I'm using. So even if I don't have a solver engine, solver add-in on this Excel workbook, I can try out different production schedules and see what profit I'll be making and how much capacity I'll be using. But our ultimate goal is to find the best schedule, which is what we will be doing in a moment. But before we let solver tell us what the best solution is, let's see if we can guess what the best solution is going to be. Now, from a profitability perspective, it looks like wide bookcases are the most profitable to make. So you might think to yourself, perhaps we should make more of these and less of these too. But then when you look at how much resource the wide bookcases uses relative to narrow bookcases and standard bookcases, it looks like it might be better for you to make less of this. So play around with these numbers for a little bit, take a little break, and then when you come back, we'll try to optimize this problem. All right, now let's see how we will set up the Analytic solver platform. At this point, you all have the add-in on your computers, and it should be showing up as one of your ribbons. I will go ahead and click on Analytic Solver Platform ribbon. I'm going to click on Model, which will give me the Model dialog box. Let's move this here a little bit so that we can see the problem. Perfect. In here, there are several ways of setting up your model. I'm going to show you how to use the Model dialog box to create your model. We're going to go ahead and expand optimization. I'm going to click on Objective, and I'm going to push plus. Typically, if you push the plus sign, it will choose whatever cell you're on as your objective. Obviously, we don't want this to be our objective, so I'm going to go ahead and right click on this and say edit, and then I'm going to say, well, I'd like to set F8 as my objective, and I'm going to go ahead and maximize that, and I don't need to choose anything else here, and I hit OK. Now we set our objective. The next thing is going to be our variables. I have normal variables. We will never use recourse variables in our class. I highlight my decision variables, C5 through E5, and then I go ahead and push plus. Now as you can see, it says, well, you have normal variables, C5 through E5. Perfect. The next thing I need to do is add my constraints. Again, I go to normal. For the constraints, you push plus again. It gives you a dialog box. It says, well, what is your cell reference for the left-hand side? Well, I want these to be less than or equal to these. Now, since all three constraints are in the same direction, are less than or equal to constraints, I do not need to enter the constraints one by one. But if a few of them were less than and a few of them were greater than, then I'd have to do it one by one or other smaller blocks. But since all three constraints are of the same direction, I can enter this block less than or equal to this block. And I'll take care of the constraints one by one. I hit OK. So now I have my objective, I have my decision variables, and I have my constraints. I'm almost ready to go. The last thing I'm going to do is go to engine. Automatically select engine is a good choice. You don't need to change that, but know that there are other options here. For a simple problem like this, for a linear programming problem like this, which we'll talk about what that means more in class, standard LP quadratic engine would also work if you don't want an automatic choice. And then you go back to the model and you push the green button to optimize the problem. So we got a solution. I need to make this bigger to see my solution. So let's take a look at this now. We are making 150 standard bookcases, 300 narrow bookcases, and none of the wide. The trimmer and the shaper constraints are at their limits, and the assembly one is not. If a constraint left hand side and a constraint right hand side is equal to one another, then we call that a binding constraint. So these two are binding, and the assembly constraint is not binding, or we can call it non-binding. What we mean by binding versus not binding is that if you have a binding constraint, that constraint shapes the optimal solution. And if you have a non-binding or not binding constraint, then it doesn't really have too much immediate effect on the optimal solution. What do we mean by that? Now, imagine this. You right now have 600 hours of assembly. If you had a few hours less or a few hours more, would the solution change? The answer is no, because of the 600 hours that's available, we're only using 180 hours. So this means I can have 100 hours less or 200 hours less, and I will still be able to make the same number of bookcases. And if I had more than 600 hours, I will still have a lot of extra hours and I won't really need to use them. Whereas the trimmer and the shaper hours are at their limit, so if I had more of one of these or both of them, I might be able to generate a better solution, or at least a different solution. When you get the optimal solution in an optimization problem like this, you may want to run some sensitivity analysis, parametric analysis. For example, let's analyze what happens when the profit for white bookcases goes from $10 to $15 with increments of $1. At what point will I actually start making white bookcases? In order to do this, I will go to cell E8 and I'm going to define it as an optimization parameter. So here's what I do. When I'm in cell C8, I go to the solver ribbon. I go to parameters. Under parameters, I choose optimization. It asks a lower value and upper value in a base case for the parameter. I'll say, well, we'll start with 10, go to 15, and then the base case is 10, which is what we had in the original problem. And then notice that now in C8 I have 8, in D8 I have 6, but if I go to E8 I no longer have a single number, I actually have a function, an optimization parameter function. And if I want to run this optimization model several times from $10 to $15 for white bookcases, this is what I do. I go to reports, I go to optimization reports, I choose parameter analysis. It asks me which result cells I'd like to see. Well, I want to see what happens to all decision variables and also the objective function. And then which parameter do I like to vary? There's only one parameter I defined in this particular template. It's E8. And then I choose E8 and push it here. If you want to remove this back, let's do that. You highlight it and remove it. And you can choose it back and bring it back here. Then it asks me what are your major access points. So which means it's asking me between $10 and $15, the values that I have for E8. How many results do you want to see? Well, including 10 and 15, I want to see 6 results. That will give me 10, 11, 12, 13, 14, and 15. Now I have set up what I would like to see for each parameter value. I set up which parameter I want to change and then how often I want to change it, and then I hit OK. As you can see, the moment the profit for the white bookcases goes from $10 to $11, I actually start making them. Look at the time spent on each operation for each bookcase and see why at $11 I actually start making the white bookcases. See if you can guess an intuitive way of why that would make sense. So this concludes our first example.